Okay, 7.2, it says verifying solutions to differential equations. Okay, what are we really doing in this section? Okay, you know how when we take the integral, an indefinite integral, we always end up with something and then it's plus c. We're going to find c, and so we can get it to be a particular equation instead of this kind of random equation that has many, many possibilities to it. Okay, but it might be presented to you in different ways. Okay, so this first one says, a curve has a slope of 4x plus 5 at each point x, y on the curve. What is an equation for this curve if it passes through 1, 4? Okay, so there's some graph is really what it's telling me. There's some graph. When it says curve, it means there's a graph. I can call it f of x. I'm going to call it y. It has a slope. Slope is my change in y. Let's call it dy dx. Let me write it down here. Dy dx equals 4x plus 5. Okay, what is an equation for this curve? So I want to figure out what y equals if it passes through 1, 4. Okay, now they gave me dy dx. I want to find y equals. How do I find y equals? Yeah, it's the derivative, so I'm going to take the integral. Okay, the integral of dy dx is y. The derivative of, or the integral of 4x. So that's going to be, I'm going to raise it a degree, so it's 4x to the second. And I'm going to divide it by 2. So 4x to the second divided by 2 is 2x to the second. For 5, let's raise it to a degree, so now it's 5x. And then I'm going to put plus c, which is pretty good, except that they want the actual curve if it passes through 1, 4. So at 1, 4, I'm going to plug 1 in for x here and here, and I'll plug in 4 in for y. So I'm going to get 4 equals 2 times 1 squared, which is 2, plus 5 times 1, 5, and then plus c. So 4 equals 7 plus c, so subtract 7, negative 3 is c. Okay, now that I have this c value, I can go ahead and write my particular equation. So I had 2x squared plus 5x. Instead of putting plus c, I now know that c is negative 3. Okay, so this is the equation of the curve. It has a slope is 4x plus 5, because if I take the derivative, 2 times 2 is 4x plus 5. Derivative of this is 0. And it passes through 1, 4. If I plug in x equals 1, it will give me an outcome of 4. Okay, let's go ahead and try another one. Actually, no, let me pause and tell you. Okay, another name for this kind of problem is it's called an initial value problem. Because they gave you a derivative, they gave you some value, and you can use that value to find the constant and then find the actual function. Okay, anyways, let's look at example 2. Example 2 says, if dy dx equals e to the 2x minus 2x squared, find the particular solution of y if y of 0 equals 4. Particular solution of y means they want me to find y equals, and they want me to solve for the constant. So I have the actual c value in there. Okay, which same thing. If I have dy dx and I want to find y, I will find the integral. So let's do the integral of this and the integral of this. The integral of dy dx is y. Okay, now the integral of e to the 2x. Well, the integral of e to the x is e to the x. So let's just start with this and then we're going to play with it. I could also do u substitution, but that's a lot of work sometimes. Okay, if I do the derivative of this, I'm going to have e to the 2x, which is fine. Then I have to times it by 2. So I need to think what was here. So when I times it by 2, it actually goes away. So it must have been 1/2 e to the 2x. Because the derivative of e to the 2x is e to the 2x. And then if I multiply by 2, these cancel and I end up like this. I know, big brain. Okay, now power rule. 2x to the second, I'm going to raise it a degree. So what do I get? I get x to the third, and then I'm going to divide it by the new degree. So this is going to be minus 2/3 x to the third. This is indefinite, so let me put a constant value. Okay, particular equation, I want to find c. What do they give me? They give me that y of 0 is 4. Or you could say at x equals 0, y is 4. You could say at 0, 4. Or at y of 0 equals 4. Let's say at y of 0 equals 4, even though I think that looks weird. Okay, so I'm going to plug in 4 for y. I'm going to plug in 0 for x. So this is 1/2 e to the 2 times 0. 2 times 0 is 0. Minus 2/3 times 0 cubed. 0 cubed is 0 plus c. E to the 0, 1. 1/2 times 1 is 1/2. Okay, I'm going to subtract 1/2. I'm going to get 3.5. We don't put mixed numbers. Let's make it improper. 3 times 2 is 6. 6 plus 1, 7/2. Which means my particular equation is y equals 1/2 e to the 2x minus 2/3 x cubed, and my constant is positive 7/2. Okay, so I found the particular solution of y. So y equals, there's no weird constant. If I do y of 0, I should get 4. And if I take the derivative of y, I should get this expression here. Okay, if d squared y over dx squared, so the second derivative, equals 1 over x squared plus the quantity 1 minus 2x squared, find a particular solution if y prime of 1 equals 7/6 and y of 1 equals 0. Okay, so we're going to have to do quite a bit to get here. Okay, to start off, let's just take the derivative, or take the integral. So if I do the derivative, second derivative, sorry. Okay, I'm going to rewrite this as x to the negative 2, because it makes it easier for me to do the power rule. Okay, if I do the integral of this, it's instead of being the second derivative, it's going to be the first derivative. Okay, this is power rule. So since this was x to the negative 2, let me raise it a degree. So now it's x to the negative 1. And then I'm going to divide by negative 1, which just makes this a negative. Okay, now the integral of 1 minus 2x, quantity 1 minus, yeah, let's do a substitution here. Where should I put this, on the side? Okay, let's do the integral of this thing. Like, where did the dx, see this weird dx squared is? You can give it to the other side and you can kind of play with it. So we're going to, we're not going to worry about it for a second. Okay, so what should I make u? My guess is u is going to be this quantity. Okay, so now this is going to be u squared. Let's do du. Du equals negative 2 dx. Is this in the problem? Here's dx. Let's solve for dx. Divide by 2, so I'm going to have negative 1/2 du equals dx. Let me write this nicer though. I'm going to put the negative 1/2 here. I'm going to put the du here. Okay, let's try to get this. Okay, take the integral, power rule, u squared. I'm going to raise it to u to the third. And I need to divide it by 3. Okay, so let me write this out. You could do it in one step. So I had negative 1/2. Now I'm dividing it by 3, which is 1/3. And then what else? Okay, and then let me put plus c. Okay, now I can plug the 1 minus 2x, but I'm going to end up writing it here anyway, so let me go ahead and move it over here. Okay, this is a sidebar. PS. Okay, so plus, what was it? So that's going to be negative 1/6. Actually, let me put minus then. Minus 1/6. For you, it's 1 minus 2x, and now it's to the third power, and then plus c. Phew. Okay, now let's look at the information they have given me. Okay, what did they give me? They gave me that in terms of the derivative, they told me that y prime of 1 is 7/6. Since I have the equation for the derivative, let's go ahead and try to use that to find our first constant. Okay, so y prime of 1 is 7/6, which means the derivative at x equals 1 is 7/6. So this is saying that 7/6 is equal to. Okay, let me plug in 1. 1 to the negative 1 is 1 over 1, which is just 1. So this is negative 1 minus 1/6 times 1 minus 2 times 1. 1 minus 2 is negative 1. Negative 1 cubed is negative 1 plus c. Okay, let's just try it. Plus 1/6 plus c. Okay, well, if I minus the 1/6, I get 6/6, which is 1. And then if I plus the 1, I get 2. So I get c equals 2, which means I can actually complete my derivative equation now. So dy dx equals negative 1 over x minus 1/6, 1 minus 2x cubed, and now plus c, which I found to be 2. Okay, now am I done? No, I'm not done. I want to find what y equals to, and they tell me that y of 1 equals 0. So let's take the integral again, shall we? Okay, where should I go? I'll go lower. Okay, so if I take the integral again, what do I get? The integral of dy dx is 1, not 1, y. Whew. Okay, now I have negative 1 over x. If I integrate that, the integral of 1 over x is ln x, actually absolute value. So this is going to be negative ln of absolute value of x. Okay, now I need to do the integral of this thing, which we kind of did up here, so I know it's going to be some type of u substitution. We're going to just try and see if we can do it without the u substitution. We can always fall back on u substitution if it turns into a big mess, but sometimes we can kind of figure it out by going backwards. Okay, so let me just bring over the negative 1/6 because I have confidence. Well, because it's already there. Okay, now if I do the integral of this thing, I know it's going to be to the 4th now. Let me leave some space for all my coefficients. Okay, and then if I'm raising it to the 4th, I need to divide it by 4. Let's do times 1/4. Okay, now what am I forgetting? Chain rule. If I take the derivative of this, I need to times it by negative 2. Since I'm doing the integral, I need to divide it by negative 2, so we'll do times 1 over negative 2. I think we got everything. Okay, we could always do u substitution if we're not sure, but I think we got everything. Okay, the integral of 2 is 2x. And now I have another constant. I'm going to call it c again, although sometimes we change the letter just to make it less confusing or less ambiguous. Okay, I have my y equation. What did they give me? Y of 1 is 0. Okay, y of 1 is 0. Or you could say at 1, 0. Okay, let's try it. 0 equals negative ln of 1. Well, absolute value of 1 is just 1. Let's go with it. Okay, what is this? Negative 1/6 times 1/4 times negative 1/2 is positive 1 over 48. 1 minus 2 is negative 1. Negative 1 to the 4th is just 1. Plus 2 times 1 is 2. Plus c. Okay, now what is the ln of 1? 0. So this is just 0, so I'm not going to worry about it. So I want to just solve for c. So what is c going to equal? C, I'm going to minus the 1 over 48. I'm going to minus the 2, so I'm going to get negative 2 and 1/48, which I don't like because mixed numbers just never work out. 2 times 48 is 96 plus 1, so this is the same as negative 97 over 48. Okay, let's find our y equation now. So y equals negative ln of the absolute value of x. And what was that? Plus 1 over 24, 1 over 48, quantity 1 minus 2x to the fourth, plus 2x. And now we can add our constant, which is negative 97 over 48. Okay, now how could I check this? I absolutely could. Okay, I could plug in 1, make sure I get 0 from this function. If I take the derivative of this, I should get this. And then if I plug 1 into this, I should get 7/6. And then if I take the derivative of the derivative, I should end up with what they gave me at the very beginning. Okay, one more. Last one. Okay, for what value of k will y equals k e to the negative 4x minus 2 times sine of 5x be a solution to the differential equation y to the second derivative of y plus 25y equals negative 82 e to the negative 4x? Okay, let's read again. What are we even trying to find? We are trying to find k. Okay, what do they give me? Okay, they give me this expression, and then they also give me the equation of y. This has a second derivative. Let's just start with this y thing, and then keep taking the derivative till we find something we can do with it. Also because taking the derivative is easier than doing the integral. Okay, let me rewrite it. Okay, let's take the first derivative of this thing. Okay, the derivative of e to the negative 4x is e to the negative 4x. So this is the same chain rule times the derivative of negative 4x. So times negative 4 minus the derivative minus 2 times the derivative of sine is cosine, chain rule. So now times the derivative of 5x, which is 5. Okay, I'm going to make this look a little nicer. So this is negative 4k. And remember, k is just some random constant. Minus 2 times 5, 10 cosine of 5x. Okay, now let's do the second derivative because I see that that is given to me in some format. Okay, let's do it again. So let's see, negative 4k. K is just a constant. So don't think of it as a variable, just like 4 times 5, 20. It's just a number. I just don't happen to know what number it is right now. Okay, so the derivative is going to be negative 4k e to the negative 4x, and then chain rule. The derivative of negative 4x is negative 4. Minus 10. The derivative of cosine is negative sine. So let's give the negative here. So this is going to make it positive. And then chain rule times 5. Okay, let me make it look a little nicer. Negative 4, positive 16k e to the negative 4x plus 50 sine of 5x. Okay, I got this second derivative. Now what am I going to do with it? Okay, well, the only other information they gave me was that this is a true equation. So let's go ahead and plug into that equation. Okay, so it says y double prime plus 25y. So I'm going to write what y double prime is. Plus 25y Oh, wait, I know what y is. Let me plug in for y as well. Where is y? Y is this thing. K e to the negative 4x minus 2 times the sine of 5x. Okay, so I did y double prime plus 25y equals negative 82 e to the negative 4x. Okay, let's just try it and see what happens. Okay, let's simplify it. Okay, what do we got? These cancel. Okay, that's an optimistic sign. Okay, and then we actually have a lot of like terms, so let's combine these together. 16 plus 25, 41 e to the negative 4. Oh, I forgot my k. Hold on. 41k e to the negative 4x equals negative 82 e to the negative 4x. Okay, now e to the negative 4x is never going to equal to 0, right? E to the anything is always going to be positive, which means I can cancel them on both sides. I'm going to divide them both off. So I have 41k is equal to negative 82, which means k is equal to negative 2. Okay, is that what I was looking for? Yep, for what value of k? Okay, so after all of that, I found that k equals negative 2.